Okay, good morning, everyone. It's my pleasure to introduce this morning Alejandro de la Fuente Pinero. He's originally from Spain and cut his teeth in tropical rainforest studying jaguars in South America, in Chile, Bolivia, and Peru. So he's been around the block a bit. I met him about 4 years ago now up at James Cook University, where we were both doing our PhDs. He's just coming towards the end of his, and he's now going to give us a little talk about it. But I would say he's a fantastic modeler person, and I can't think of anyone else I'd rather get scrubbage with. So it's going to be a great talk, and you can all look forward to it. There you go, Alejandro. Take it away.
Thanks, Tom. Thank you, everybody, for having me here today. It's my pleasure to be presenting this seminar today. Unfortunately, it's not a very cheerful one, as you can already imagine by the title of my presentation. However, I hope I can convey in the next half an hour or so the crisis that we are facing in the rainforest of Northeast Queensland. To kick things off, I want to show you 2 photos of myself. The photo on the left-hand side was taken in the early 90s when I was very little. I was dressed up as a grandpa for carnival. And the photo on the right-hand side is far more recent, from 2021, actually, taken in the Australian West Tropics when I was already doing my research. The reason I want to show you these 2 photos is not just for you to see how cute I was when I was little, but because they represent the time frame that I'm going to be talking about today, which also happened to be the 30+ years that I have been alive. In this time, the concentration of CO2 in the atmosphere have risen all the way from 356 parts per million, around when the photo on the left was taken, to 417 parts per million, around where the photo on the right was taken. This abrupt change in the atmospheric conditions is happening before our own eyes, before my own generation, within my own lifetime. The consequences of the increase in CO2 in the atmosphere are evident, and perhaps one of the most known one, or the one that we can measure most accurately, is the increase in temperature. Here, I'm showing you the stripe plot, the classic stripe plot for Queensland. Although if I were to show you anywhere else in the world, any other region, this will look very, very similar. So this is basically representing the deviation from the mean and historical temperature, and values in red represent a warmer year, and values in blue represent a colder year. Now, the time frame that I was introducing you before is contained within this white rectangle, which also happen to contain most of the warmer years. This means that the increase in temperature have been quite evident in the last 3 decades. And in Queensland, and in particular in the West Tropics and in tropical North Queensland, an increase in temperature translates directly into an increase in heat waves, because the intra-annual variation in temperature in this region is very low. Biodiversity is obviously responding, and I'm going to be showing you here a few facts for which we have a really high confidence that they have happened or that they are currently happening. And this is perhaps one of the most impactful studies that went into the latest IPCC report. So it is absolutely clear that species in all ecosystems, without exception, are responding. Perhaps the most predominant response of a species is a change in the distribution. So species are moving. And the reason for this is because the habitats that they used to live in, they are slowly or rapidly becoming unsuitable. And therefore they are moving towards colder habitats, usually related to higher latitude or higher elevation. However, this shift doesn't come without a cost. And across all species that have been ever studied in terms of population dynamics, half of them have shown a significant decline in population. But not only that, extirpation, which is the local extinction of a population within the distributional range of a species, is actually the most common trend in tropical mountains, in tropical ecosystems, with 55% of all extirpation that have been observed around the world happening in the tropics. Within the tropics, mountains are perhaps the most threatened ecosystem. And this is because they have a really strong elevational gradient that define a thermal gradient, and therefore with an increase in temperature is the one that is expected to have the hardest hit. And within this tropical ecosystem in these mountains, the most dominant driver of biodiversity erosion is extreme events. Because these tropical mountains also happen to condense a really high proportion, a disproportionate amount actually, of endemic species around the world, is quite critical for the conservation of these species. And currently, 84% of all the endemic species that live in the tropical mountains are now facing extinction. This is the case for the Australian wet tropics, which is a tropical ecosystem that is defined by mountains and also holds a disproportionate amount of the biodiversity in Australia, holding very high amount of endemic tropical species. To show you what is going on in this ecosystem in terms of climate change, I want to start by showing you a really particular example, which is the case of rainforest ringtail possums. This perhaps is one of the species that is showing the most dramatic change and is actually showing what is going on in the Australian wet tropics very accurately. For those of you that are perhaps less aware of these species or have less knowledge of these species, rainforest ringtail possums are a group of marsupial folivores. This means that they feed predominantly on foliage. They are rainforest canopy species. They almost never go to the ground, and therefore they are quite restricted to pristine rainforests. They do very badly in fragmented areas. On top of this, these species, although endemic to the Australian wet tropics, they are not widespread, and they actually are restricted to the highlands of the region. For example, the species I'm going to be presenting in this first example is the lemurid ringtail possum, this little fella here on the right. The core population of this species is around 900 meters in elevation. To put it in context, the average peak height in the Australian wet tropics is around 1,000, 1,100 meters. So you can get a feeling of how close to the mountain tops these species already are. And with that, it has attached a number of vulnerabilities to climate change. First of all, these species suffer of a very small geographical range, and the population experience high isolation. And this is just because of how mountains are shaped. As you go up in elevation, total area decreases and the isolation increases, just because different population might be in different mountains altogether. On top of this, because these species live in the tropics, they have very low thermal plasticity because they have evolved in an area where temperature doesn't oscillate that much. These characteristics that I am showing for the lemurid ringtail possums are not unique, and they are actually shared by most of the endemic species in the Australian wet tropics. Most of them are rainforest specialists, and most of them are living in the highlands of the region. The Australian wet tropics is a World Heritage Area, and here is the limitation of this such area, and its location within Australia is in the northeast Queensland, roughly between Townsville and Port Douglas. Here in gray, dark gray, is the coverage, rainforest coverage of the region, and the yellow star are the long-term monitoring sites that were established by my supervisor, Steve Williams, in 1992. These sites are selected to cover not only the latitudinal gradient across which this species occurs, this distributional pattern across latitude, but also the elevational pattern. So the lower elevational range of ringtail possum is around 400 meters, which is the lowest of our sites. And then they go all the way up to mountain tops. So we are covering basically the entire distribution of these species in our monitoring effort. In terms of how the data was collected and the data that we're working with, we have 32 different sites that were the yellow star in the map before, and we have been continuously collecting data for 31 years, starting in 1992 and continuing in the present. Basically, what we did is we have 1 kilometer transect in the rainforest, which we survey following a standardized methodology to keep this consistent, obviously. And we do a spotlighting counting the number of possums. There are 4 species endemic to the Australian wet tropics, and we consider all of them. And we also gathered information about the weather condition during the survey to be able to model as well the detection probability of these species in order to produce unbiased estimation of population size. I showed you before of the overall stripe plot of climate change in Queensland, but we also have information for what is going on specifically in the wet tropics. And this data is coming from Walker Research Station, which is a bomb station that is at the heart of the tablelands in the middle of the Australian wet tropics. Something that I'm going to be doing during this talk, and I do during my research, is splitting climate change into different dimensions, depending on how we believe they impact biodiversity. And this is called a press pulse scenario. Press is just a pressure, something that is consistent and gradual. And a pulse, on the other hand, is something more located in time and space, is usually related to extreme conditions. So on the plot on the left, we have the press, which is the change in mean annual temperature during the study timeframe between 1892 and 2021. And on the right, we have the pulse, which is the observed number of extreme hot days over 35 degrees. This is around 99.5 percentile of maximum temperatures in the region. Overall, in these 30 years, the mean annual temperature have increased a little bit more than half degrees. And this is just consistent with what is happening globally. And in terms of heat waves, there have been quite a lot of fluctuation in the first 2 decades. However, after 2010, there is an exponential increase in the duration and intensity of heat waves in the region, breaking historical records after 2014. And on average, we now have around 8 more extreme days per year, usually concentrated in the wet season. So what we did here is basically we modeled the population dynamics of these species across these 32 sites and 31 years. And I'm going to be showing you a summary of the entire trend of population dynamics of these species. This is the plot I'm showing you here animated on the left, where we have the time frame on the bottom of the slide, the x-axis, and we have the black line representing the population dynamics across the entire distribution of the species. In the same plot, I'm showing you the temporal variation in heat waves in the region. And something that is very clear is that the population of lemon ringtail possums are basically mirroring whatever is happening with heat waves. This becomes very dramatic after 2010, where the exponential increase in heat waves meant the collapse in ringtail possums. In those 11 years, the population across the entire distribution of the species have declined by 75% on average. And since the beginning of the time series, where we assume that the population was in healthy conditions, we have lost 64% of all the lemon ringtail possums. This pattern is just a summary across all the study sites, but what is actually going on is an extirpation. So the lowland population of these species are becoming extinct, and the highland population are declining very rapidly. This species used to be present all the way down to 500, 550 meters, and now is rarely observed below 800. So this is quite a dramatic increase in elevation in just a short period of time. On the right-hand side, we have a summary of the posterior distribution of the slope. So this is basically the effect of the press and pulse framework. We have the pulse, which is the extreme heat wave, showing a strong negative influence of the population dynamics, being the main driver of population change. However, when we look at temperature trend, which is the pressure, the mean effect is close to zero. So this means that the main driver of population change for ringtail possums, as you can already see very evidently by the covariation, is heat waves. So they are extremely impacted by heat waves. So after seeing this, we were wondering what would be the future for this species. So using the latest IPCC report, we were wondering what was going on. So this is you might be familiar with it already. From the latest CBCS report is the relationship between temperature on the y-axis and the accumulation of CO2 since pre-industrial era on the x-axis. And this is directly related to a time frame, which is presented here at the bottom of the slide. In gray is the observed change in mineral temperature over time. And the different colors represent the different scenarios of global warming. What worries us, and what is very concerning, is that all the scenarios are overlapping and they are increasing linearly. This means that we have high confidence that the temperature between 2020 and 2050, which is where these predictions were made, is going to continue increasing linearly as we have been observing before. And this is because the attenuation and amelioration of emissions before 2050 is now beyond reach. So using this certainty of what is going to happen, at least predicted by the IPCC, we took this variation in temperature in the future and incorporated it into our population model to forecast how the population dynamic of ringtail possums will be doing in the future. The result of these predictions are here shown in red, and in black are the same pattern that I showed you before in the dynamic plot. It's just the predicted population size across the entire distribution from our population model. Basically, what we found is that the population of ringtail possums are going to continue in a free fall between now and 2050. We paired this analysis with a population viability analysis. What we did here is use different thresholds that usually are used by the IUCN to define whether a species should be categorized as endangered or critically endangered or vulnerable. And they are also matching very closely to what we know as quasi-extinction threshold. A quasi-extinction threshold is just a population size below which it is believed that the species will have a really hard time recovering from. So if the species fall below a certain threshold, the population is considered low enough for us to have concerns about whether they can naturally recover. We use a huge variety of different thresholds, and I'm going to show you here the most dramatic two, which are a 70% population loss compared to a healthy population, which we assume was at the beginning of the time series, and 90% population loss. So what our model shows with really high confidence is that this species is going to reach 70% population loss relative to the beginning of the time series before 2035. And a 90% population loss will be reached before 2048. So this is quite a lot. This is obviously if four main assumptions are met. The first is that we are capturing the relationship between ringtail possums and temperature and heat wave accurately, which we believe we are. Second is the IPCC predictions are correct, and the temperature and heat waves are going to increase as we are expecting. Third is the ringtail possums follow or respond in the same manner in the next 3 decades as they have been responding for the last 3 decades. And fourth, if we do nothing about it. So coming back to the side story, this is how the population of ringtail possums were when I was little. This is where we are at now, at the moment, the population of ringtail possum at the present. And this AI-generated version of myself wonders if in 30 years we will be able to see ringtail possums ever again. So this is just one species. And many of you might be thinking, well, might be one-off, might be just one species that is quite vulnerable to climate change. There is no reason to say that it's a sign for an imminent collapse. So let me help widen our perspective, and let's look at other taxes that we have data for. And this is rainforest birds. For this case, we, in the same areas, the Australian wet tropics, data set for birds is much longer. So we have more sites. Remember that for possum, we have 32 sites. For bird, we have 124 different sites across the entire Australian wet tropic World Heritage Area. However, the time frame is a little bit shorter. These were monitored for 17 years but we have enough data to model the population dynamics of up to 47 different species. So what we did here, I'm showing you the summary of the main study looking at the escalator to extinction that is going on with the other vertebrate, in this case, rainforest bird in the southern tropics. For all those of you that are familiar with these indices, this is very similar to the Living Planet Index, in which you basically collapse the dynamic of multiple species into one index. And the first year of this index is set to 100. And then the following years of the changing population is relative to this initial year. The x-axis here is the time series between 2000 and 2016. And the different columns here, different plots, represent communities, community of birds. So the lowland species are birds that in the year 2000, so at the beginning of the time series, 75% of the population of these birds were concentrated below 450 meters in elevation. Midland species are those birds in which in the year 2000, the population, 75% of the population were between 450 and 900 meters. And upland species, as per the possums, will be species which population are concentrated above 900 meters in elevation. So what is showing this pattern? What we are seeing here is the lowland species here in this first column of the plot is undergoing a really huge increase in population. And this is because they are going up. They are shifting the distributional range higher up in elevation. And something that happened in the tropics is that the lowlands are quite fragmented because of agriculture. But the total area of rainforest actually increases towards the midland. So these species are finding new habitats as they are going up in elevation, and therefore they are expanding, increasing exponentially in population size, although towards the last part of the time series, the population seems to stabilize. On the other hand, midland species are declining in population, and this could be due to two things. It could be due to the fact that lowlands are getting warmer, and therefore these species are declining in the lower part of the mountain, or also could be happening that these species are declining because they are competing now with these new species going up in elevation, or both at the same time. However, what we know is that these midland species are remaining stable in the higher elevations. So that means that they have still a little bit of room to recover as they have still mountain above them. The problem becomes again for upland species, the same as for possums. And we have that these species have nowhere else to go up in elevation, and therefore they are collapsing in population, and the decline is massive. So very similar way to what we see for possums. We pair this analysis again with the press and pulse framework that we saw before. And because we have far more species, we were able to expand our analysis. And we have two presses, which are mean temperature and precipitation, and three pulses, which are heat waves, drought, and cyclone. This is a bit complex, so let me just focus on temperature, which is what we are going to be related back to possums. Here I'm showing you two different plots in different columns. The column on the left is showing the species-specific response to this parameter. So each point is a slope or an effect. And on the right, we have again the community average. So this will be all the species that occurs in this elevation, etc., etc. The elevational range here is based on which is the main or the core population of this species. So for example, this species over here will be a species that has the core population around 200 meters in elevation. And this will be a population of a species that has this core population in the mountain tops. The pattern that we're seeing here in this first plot on the left, the mineral temperature, is that lowland species, as expected by this escalator to extinction hypothesis, they are responding positively to warming. So as the mountain warms up, these species are increasing in population. And this effect shifts very gradually, but consistently as you go up in elevation. Remember, as you go to the right, means that the population is higher up in the mountain. And once we surpass the 900 meters category here in elevation, the species start showing a negative effect or negative response to the same driver in the same magnitude. So they are basically mirroring what is going on in the lowlands, but in the opposite direction. So this is what we call the escalator to extinction, basically. In terms of the pulses, because we have a really wide diversity of species with different traits, life histories, diets, sizes, and physiological responses, it seems to be quite a species-specific response, especially when we look at drought and cyclones. I'm not going to be showing you right now. I'm happy to answer questions about that later. However, I want to highlight a very interesting pattern that we found here for the lowland species. And this is that the lowland species, to the same kind of trend, which is the thermal trend in the wet tropics, they are responding differently when we are talking about gradual warming or the press and extreme heat waves, the poles. They're responding positively, as I just was commenting before, to the warming, but they are negatively responding to heat waves. This is not really strong. In fact, it has quite a high uncertainty and the effect is not very strong. But it's still very interesting that the same population are responding negatively to the heat waves when they are responding positively to warming. And this is because what is going on here is that the population in the lowland, so in the lower part of the mountain, they are declining. But they are increasing so much in the midlands that the total population is compensated. However, this is called, in ecology, abiotic attrition. And the lowlands are emptying. So what is happening is that there are no population colonizing the lowlands, and the lowlands are emptying of biodiversity. So far, of all these species that we have been exploring, around 51 species, 15 of them are collapsing. And due to this collapse, they have been incorporated in different conservation categories in the EPBC or IUCN. And all these 15 have something in common. They are all rainforest specialists, and they are all upland species. So this, we are starting to see a very common pattern in the tropics. However, this biodiversity erosion is not restricted to vertebrates, and this is also happening across the entire ecosystem in tree species. And this is from a very recent study from Bowman. They were looking at tree mortality in the Australian wet tropics. And I'm going to show you here a very similar trend to what it seems to be happening for possum and birds. Here in the first plot on the top, we have our mortality risk across time. And what we see is that we have a really consistent pattern in terms of mortality, very low mortality overall, and it started increasing after 1990, which is around where we have our first data on possums and birds. The mortality increases, but when it really starts kicking off is after 2010. The same for possum and the same for birds. And this is really interesting because trees have totally different time frame, totally different generation time and life cycle. However, they are responding very similarly to what is going on in the tropics, suggesting that the impact of climate change is happening very dramatically. The second plot, we have a site-specific response, in this case for each CSRO plot across where this tree mortality was measured. And the reason the author, I believe, put this here is that it looks very similar to the stripe plot I was showing you before for Queensland. As you go to more recent times, the colors are becoming more red, which means that the death or percentage of death in a particular plot increases over time. And the main driver of this tree mortality in the Australian wet tropics is the annual maximum vapor pressure deficit, which is something where it's called that the trees are drying out because the atmosphere is getting water thirsty. And this is also related to temperature. So it's all connecting together into the same fashion. So finally, I want to just reiterate some take-home message that I hope I have conveyed throughout this presentation. Something that is really important is to identify and to be aware that protected areas are not always safe. And this is particularly the case when we are talking about climate change. the Australian Wet Tropics is a World Heritage Area with the high level of protection and almost zero human intervention. It's very well managed, and still we are observing most of the dramatic changing in biodiversity that we are basically observing around the world. So it doesn't matter if it's a national park, a protected area, or a World Heritage Area, species are responding to climate change in the same way. I hope I have convinced you that climate change is the main driver of population decline, local extirpation, definitely distributional shift, and also mortality directly, as we have seen for the trees. This is not a one-off, and it's actually a widespread pattern that is affecting different generation times, trees, birds, mammal, basically everything that we have data for. So I wouldn't be surprised if this is going on as well for other taxas. Endemic species, because they are upland restricted, are the ones that are suffering the greatest pressure, which is particularly concerning because these species, this is the only place in the world where they are occurring. So this could mean the extinction of these species in a very short time. The short-term climate change attenuation, as shown by the IPCC, is now beyond reach. So it's very likely that in the next 3 decades, the impact of climate change on the region are going to be increasing and accumulating, as we have been observing for the last 3 decades. So I want to leave an open question that I hope now you can help me understand, or maybe give me your input, is whether are we observing a collapse of an entire ecosystem before our own eyes within my own generation? Thank you very much.
The questions in the room for Ale? He can hear you, so just speak. Yeah.
I just wanted to ask, like, we are seeing this trend in like declining population for higher taxons. What about lower taxon group, like non-chordates and like non-vertebrates, assuming they might have higher rate of hybridization and like higher rate of mutation in them for like like moving towards speciation rather than adaptation to the different environment.
Yes. What was the question, sorry?
I think the gentleman was asking, tell me if I'm paraphrasing this wrong.
Yeah.
Do you think that the population declines you're seeing would be reflected in species like invertebrates because they're going to have more of a propensity, given their short generation time, to adapt quickly and speciate rather than simply declining in a very rapid manner? Do you think you'd see those same patterns reflected in invertebrates?
For invertebrates, I think we are going to see, if it's not already happening, I should say it's already happening, a similar pattern that we are seeing for lowland birds. And I'm expecting that they are going to increase in population, basically because the midlands are warming up and the lowlands are warming up, which means that they are opening up a space for invertebrates to colonize. What I don't know is where it will be the threshold for these species to actually start declining after the increasing temperature. But what I will be expecting is a change in the communities due to climate change. But I will expect an initial increase in population for invertebrates.
Thank you.
Anyone else?
I'll take one.
Sure.
Hi, Alejandro. This is a super interesting talk. And also in particular, I really like that graph you made with the GIF where the lines converge together in opposite directions. I guess coming from my place of being interested in the invasive species in the wet tropics, I wonder if you could speak about any interactions or links between this climate crisis and invasive species in the region, because we've got records of cats in high elevation rainforests. So I'm just curious if you have any thoughts about that.
Yeah, well, it would be difficult to relate climate change to invasions because there might be many other different factors that affect invasion, especially of big animals. But I imagine that if the invasive species are somehow restricted or the invasion is being reduced by the interaction with native species, the fact that the ecosystem is opening up, it will allow the invasion of perhaps species that weren't there before or weren't able to invade the wet tropics. So it's definitely a threat that if biodiversity is eroding, at least the native biodiversity, other species that are not native to the Australian wet tropics might be taking that position.
Thank you.
Alejandro, I have a question from the chat from Brooke Williams. Thanks, Brooke. Apart from mitigating climate change, are there any management actions that can help slow or prevent species declines? And what are your 3 recommendations for managers?
So this is something we're working on at the moment. So all the study I have done so far always left me with the same question, which is, okay, but how exactly? So we know they are declining, but we don't know how. We don't know if they are declining because they are dying. We don't know if they are declining because they are not reproducing, both. So what we are doing now is to try to answer that. There are many different strategies that come to my mind that is working on, that at least being implemented in other areas. Like, for example, for the case of ringtail possum, putting some artificial shelters to buffer a little bit the temperature that they might be experiencing. But I don't know if this will be the best strategy in a highly humid ecosystem such as the wet tropics. So what I can tell you that so far, we don't have an answer because we don't know exactly how this is happening. We know that it's happening, but we don't know how. So the management is really difficult because this is a really well-managed area. So there is no human intervention. There is two organizations, which is Queensland National Park and Wet Tropics Management Authority, actively looking after the area. So far from our perspective, we don't know what else to do. So this is something that we are going to be looking into something specific, and that what is going to be the next step, trying to identify what exactly is going on in this population for them to decline, in order to perhaps try to implement something targeting specifically the cause of this decline.
Thank you. I guess I'll take a question, LA, if that's all right.
Mm-hmm.
Given that you're sort of wrapping up your PhD and Steve has now moved down to the Sunshine Coast, and we're about to go to an El Nino year, is there any plans for anyone to carry on the monitoring to actually see the events of these, like the effects of extreme climate events, and keep this sort of time series going?
Fortunately, Queensland National Park is being quite engaged, especially for possums. The logo is a Herbert River ringtail possums. I wouldn't be surprised if they want to at least try to do something about it. And I'm very happy to see that they are conducting monitoring of the ringtail possums independently. So this is going on at the moment. Sadly for birds, it's not. So the 124 sites across the Australian wet tropics is really difficult to maintain. Requires a lot of funding, a lot of people. So far, I don't think there is anyone willing to take up at least the bird monitoring. But at least the possum, we are continuing, and hopefully in good hands with national parks.
Thank you. Any more? Any more online, Kate?
Nobody online.
All right, well, I think in that case, yeah, maybe we should just thank Alejandro for his time. It was a really great talk, well done. And yeah, his email address is there if anyone thinks of any further questions or wants to get in contact with him. He's very approachable and responsive. So yeah, great. Thank you.
Thank you.